Hello everyone, I welcome you all to this next video in the Spring Framework lecture series. In the previous video, we took a little detour and implemented a simulation of a real-world production application. The primary goal was to send out communications to the users. The crux of the problem was to send out communications using multiple email service providers. I hope that having multiple email providers did help you in understanding the concepts of beans as reusable components, dependent beans, and gluing it all together to form a cohesive application. In today's video, we will continue our journey of learning the Spring Framework. We will pick up from where we left off in the third video. I will cover the following topics in today's video. Number 1. What type of objects can be considered as beans? Number 2. Beans instantiation. Number 3. Bean lifecycle. So without wasting any time, let us get started. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. First, let me talk about what kind of objects should be thought of as beans. Theoretically, any Java class can be conceptualized as Spring Bean. However, practically, things are a little different. Recall from the last video, mapping the real world onto the software you are developing is the art of software architecture. Let me elaborate on this statement to better understand this concept. We humans develop software for the purpose of solving real-world problems with the help of computers. This has been true throughout the history. Some examples on this: Google came into existence during the time when searching on the internet was very tedious, time-consuming, and existing search results were not relevant. Similarly, Facebook as a product was conceptualized to solve the problem of connecting people with each other. Back then, people were not so connected with each other as they are today. Today, anyone sitting in one corner of the world can easily connect with people located in different parts of the world. In the early 2000s, this was not thought of. The food delivery business of Zomato was conceptualized to solve the problem of on-demand, instant food delivery. When developing software, there is some real-world idea, concept, or entity that has to be mapped as a software component. For example, a Zomato user represents a physical user. A courier partner also represents a physical user, but with a different role. With this context in mind, let us focus back on what type of objects can be considered as beans. To answer these, beans are generally Java classes which encapsulate some common functionality. Conceptually, the state of these classes are not affected by who is using them. For example, a bean can be a class which has a functionality of finding available delivery partners based on some filter criteria. On the other hand, it is generally a bad practice to have a bean for delivery partner class. There are a few reasons to this logic. Number 1. Each object of the delivery partner class may represent a different physical user. Anything related to this class is not generic and varies person to person. It wouldn't make sense for Spring to manage such instances. As we will see later, it involves a time penalty. Number 2. Classes like delivery partner are used in the system to pass information from one component to another. They are data carriers in the software. The list of delivery partner objects should be the return type from the method find available delivery partners. Delivery partner or user or vehicle or restaurant or food items are all domain classes. The objects of these classes are passed around in the application to pass information from one component to another. The information for users, restaurants, or food items will ideally be stored in the database, and these objects will be instantiated by components who are responsible for fetching data from the database. On the other hand, the component which is responsible for fetching data from the database can be thought of as a Spring Bean. I hope it clarifies the concepts of beans and domain objects in detail. I also believe it should answer the question what kind of objects can be thought of as a Spring Bean. With that, let us move to the next topic, that is bean instantiation. First of all, let us understand what is meant by bean instantiation. Bean instantiation is the process of creating an object of Java class. The lifecycle of this object is managed by the Spring IOC container. Spring can create objects of our Java classes using any one of the following three methods. Let us understand them one by one. The most simple and popular method of instantiating beans is to use the class constructor. The XML configuration examples we have seen are examples of using constructor to instantiate the beans. Doing so for the Java configuration is more straightforward. The catch here is, if the constructor arguments are expected, we have to pass them manually. They can be dependency injected as method arguments to bean annotated methods, as shown here in this example. Factory classes are those classes which itself are the source of bean objects. Spring can instantiate an object of the bean by invoking the static factory method of a factory class. The XML configuration has to be slightly modified to make this work. Here the class is not the bean class but the factory class. The factory class should have a method with the factory method argument name, and this method should be static in nature. Doing so in the Java configuration is very trivial. We directly call the static method of the factory class in our bean annotated method, as shown here in this example. We can use the instance method of an existing class to instantiate a new bean object. The existing bean is called the factory bean. The factory bean is also managed by the Spring IOC container and can use any dependency injection functionality provided by Spring. To accomplish this in the Java configuration, we first need to have a bean annotated method for factory bean. Using this factory bean, we can instantiate our original bean object in another bean annotated method. If I take a closer look, I can see that Java configuration is easier, convenient, and intuitive compared to XML configuration. Going forward, I will be using Java configuration only for my lectures. Next step is bean's lifecycle. The bean lifecycle refers to when and how the bean is instantiated, what actions it performs until it lives, and when and how it is destroyed. Before I explain bean's lifecycle in detail, let me first talk about aware APIs in Spring. A Spring bean may want to access framework-specific objects like application context, bean factory, Spring environment. However, in normal scenarios, such information is not exposed to the bean, and there is no way a bean can access these details on its own. Spring provides us with the aware and its sub-interfaces which a class can implement to get notified of these framework-specific details in a callback-style manner. For example, for a bean to get access to application context, it can implement the application context aware interface. Application context aware has a single method, setApplicationContext, which will be invoked by the Spring IOC container, passing in the current application context. The relevant class can save this application context as a class variable. Coming back to bean's lifecycle, this diagram conceptually shows the stages a Spring IOC container goes through during the lifetime of an application. The first step is to load and post-process all the bean definitions. Next, the beans are instantiated, dependency injection is performed, and the beans are initialized. Lastly, after a JVM shutdown is triggered, the Spring IOC container goes through the shutdown process. The initialization step is detailed in this diagram. Spring provides us ways to hook into the bean initialization process for any custom logic to execute. To customize the initialization process of the bean, Spring provides us with three ways. First, a class can implement the initializing bean interface of the Spring framework. This interface has a single method after property set, which is invoked by the Spring framework. Next, a class can have a custom init method, which will be invoked by the Spring framework. Spring by default is not aware about the custom init method and we have to configure it in the beans configuration. Lastly, a class can have a single method with the post construct annotation. Post construct annotation is defined in the Java EE specification and Spring supports using this annotation for bean initialization. Some important points to remember regarding initialization methods. Number 1. Initialization methods don't support method parameters. Number 2. If any initialization method throws an exception, the application fails to start. Number 3. The initialization methods are invoked on the main thread. So until an initialization method returns, application load cannot progress ahead. Because of this reason, we shouldn't do resource-intensive tasks here. I have seen developers start consuming Kafka messages in the post-construct method, which is a bad practice. Whenever a JVM shutdown is triggered, the Spring IOC container goes through the shutdown process. The shutdown process involves destroying the beans present in the application context. Spring provides us ways to hook into the bean destruction process. To customize the bean destruction, there are 3 ways. First, a class can implement the disposable bean interface of the Spring framework. This interface has a single method destroy, which is invoked by the Spring framework. Next, a class can have a custom destroy method, which will be invoked by the Spring framework. Spring by default is not aware about this custom destroy method, and we have to configure it in the beans configuration. Lastly, a class can have a single method with the pre-destroy annotation. The pre-destroy annotation is defined in the Java EE specification and Spring supports using this annotation for bean destruction. Some important points to remember regarding destruction methods. Number 1. Destruction methods are only invoked for singleton scope beans. Number 2. Destruction methods are only invoked when the application context is closed. To properly initiate the application context shutdown sequence, a JVM shutdown hook has to be registered, which should invoke the close method. Spring application context has a convenient method, register shutdown hook, which we can use to register a shutdown hook on the application context. The close method and the register shutdown hook methods are not directly exposed by the application context. Instead, we need to cast the application context to abstract application context to use these methods. Number 3. If a destruction method throws an exception, it will be silently ignored to allow other beans destruction method a chance to execute. Number 4. Destruction methods are not invoked on the main thread. Instead, they are invoked on the shutdown hook thread. Number 5. It is not guaranteed that shutdown hooks will always run or they are given a chance to finish their execution. Because of this reason, destruction methods shouldn't have any critical business logic. With that, we have come to an end of the beans lifecycle chapter. I have intentionally not talked about the bean post processors during this chapter. We will have a look at bean post processors in the container extension points video. This brings us to the end of this video. I have shared so much content with you in this video. I believe it will be useful for you. If you have some suggestions regarding the content or teaching style, do comment your suggestions. My sincere request to all of you is to practice the concepts on your own time as well. One golden rule of software engineering is the more you practice, the better you will become. As always, comment your doubts in the comment section and I will try to address them as promptly as possible. In the next video, I will cover following topics. Number 1. Bean scope. Number 2. Component scanning. Number 3. Beans wiring. Number 4. What can we inject? As always, thank you and keep learning. I will see you in the next one.